Hello everyone, welcome in this webinar for the concrete design of SIA engineer. Today I will be with you. My name is Marwan Altai. I'm a product manager working for SIA, responsible for the concrete design and the development of the engineering report in SIA engineer. Today I will be with you in the coming few minutes, and I will try to explain to you the content of the concrete design in SIA engineer version 17. And before that, I would like to ask from you to check if the sound is okay for you. If not, then please try to use the sound check in the GoToWebinar to adjust the sound. And remember, whenever you have a question, you can type your question on the question panel, and after this webinar I will try to answer the question. If the time is not enough, then for sure I will try to answer your question by sending an email for you. This webinar will be recorded and it will be published on our website sia.net and on our YouTube channel, so you can share that with your colleague or you can rewatch it later. So let's start it now. Today I'm going to give you an overview about the content of the concrete design in SIA Engineer. Then I will try to explain to you technically what's happening in the background and how SIA deal with the internal forces to calculate the reinforcement. Then we will make a kind of revision for the design of 1D member, because this topic already released since version 16 and 16.1 of SIA Engineer. Then we will go to the main topic of this webinar, which is about the design of 2D member. We will see that live in SIA Engineer, so you can feel how the design of 2D member become in SIA Engineer. The last topic of this webinar, it will be about the calculation of punching and long-term deflection. What you can do today in SIA Engineer version 17. Of course, you can design a concrete structure according to the Eurocode, and we have also many national annexes. So it's not important where you are in Europe. So probably you will find your country as a national annexes supported in SIA Engineer. You can design 1D members, 2D members, and you can calculate for those two members the reinforcement according to the ULS. That means you can calculate longitudinal and shear reinforcement. And here maybe someone will ask, can I do some SLS calculation? In fact, you cannot calculate the reinforcement for USLS, but you can check your reinforcement for SLS. I will explain that in this part. For the checking point of view, as I mentioned, we have some checks for the ultimate limited state, which is the capacity response. It's mean checking the stresses and the strain, the concrete and the reinforcement. Capacity diagram, we using interaction method diagram for the calculation of the reinforcement. So we are checking the capacity of the cross section and according to the internal forces. Then we have a check for the shear and torsion. For the SLS calculation, you can do some stress limitation, crack control, and we have very nice method for this for the calculation of the deflection, which is very simplified, very simple, but it will not give you an accurate result because it's not like the CDD. It's something simple, but you can use it, of course. And with all those three checks from the SLS and ULS, you can design your structure for ULS and for SLS. For the 2D elements, you can do the same. You can do SLS checks by calculating the crack width. We have short term and long term deflection, and we have punching check and design. I missed to tell you that, of course, you can calculate the longitudinal and the shear reinforcement for the slabs, and you can perform the long-term deflection for that slab. Next point is what's happening in the background of SIA Engineer, and why does SIA Engineer a little bit different compared with other software? Because in fact, SIA Engineer not only taking the internal forces from the calculation from the finite element method, but we do some recalculation to meet some requirement from the Eurocode. Like for instance, there is a recommendation in the Eurocode talking about the reduction of the internal forces above the support, so you can reduce your shear forces on the face of the column or at distance d from the face of the column. Also, we can increase some reinforcement. The longitudinal reinforcement can be increased due to the shear, and this is what we call it shifting rule. This is from the Eurocode. And also, when we design any compression member like column, then SIA will take something we call it eccentricity to magnify the amount of bending moment on that member to meet the requirement from the Eurocode. So my point from this slide is just to tell you that it's not only internal forces taken from the calculation or from the analysis of the structure, but we do some recalculation afterward. Then SIA looking to the design method, what you design, what method you would like to design. In SIA Engineer by default it's biaxial method, so if you have bending moment in Y, bending moment Z, then both of them are taken into account for the calculation of the reinforcement. The same thing for shear, but of course you can switch all that off and you can design for uniaxial. As I mentioned, we're using interaction diagram method. Then SIA checking the reinforcement for shear reinforcement, and we have very nice issue regarding the calculation of the angle of the compression strat, which it is automatically implemented in SIA Engineer by making a kind of iteration to find out what is the best angle for the calculation. All these articles from the Eurocode regarding the shear reinforcement has been supported. Then we have something also regarding the neglecting of some internal forces. For instance, if the internal forces is less than 10% of the major bending moment, then you can inform or you can tell SIA Engineer that you don't want to take that into account. And this is just because we have very open environment, so you have fully control on the design of when you are using SIA Engineer. Those are the articles regarding the detailing provision of the calculation of the reinforcement. And finally, as a user, I can calculate my basic reinforcement. If there is additional reinforcement should be calculated, then it will be calculated. And finally, I will get the provided reinforcement inside my cross section or inside my member. All that is supported with a nice output graphically or numerically with a nice error and warning system. This error and warning system can guide you to understand what's happening in your structure and what kind of solution you have in front of you. Now we can talk about design of beams and column, and what we have in the beam and column. In fact, we have three different workflows to design beams and column. Someone will say, why different workflows? Because we're dealing with different experiences from the people, from the designers. So it's up to you. Depending on your experience, you can decide which workflow you would like to use. For instance, I'm experienced user. When I look to the bending moment diagram, I can say from the beginning how much my reinforcement. I can expect that. And what I need to do, I need to input this reinforcement directly inside my structure, and just to be sure that my assumed reinforcement is okay or not. So if I have this continuous beam, I can add the longitudinal reinforcement and the stirrups directly, and then SIA can tell me if everything is fine or not. So the first workflow is by using the practical reinforcement, and it's for the people who already know what they are doing. The second workflow, it's when you have a very complicated situation, or when you have a little bit dangerous or critical cross section. with the difficult shape, then I recommend you to use a section check, which is an integrated tool inside SIA Engineer. This tool has very user-friendly environment. You can see on the right side all the checks from the ULS and from the SLS. On the left side, you can see your cross section with an easy way to input the reinforcement, and in the middle you can see the content of the check with some colors to guide you if everything is okay or not. The third method or the third workflow for the designing of 1D member, it's I call it as a very common method which can be used if you have many elements in your project. If you have multi-story buildings and you have many beams, many columns, and you want to achieve all that in very fast way, then what you should do? In that case, I assume that you will put a basic amount of reinforcement everywhere inside all these beams in one click, and then you are waiting from SIA, or you are expecting from SIA engineer to see where you have the extra bars, where you have the additional reinforcement. And for that purpose, we prepare this kind of library, which is also a very user-friendly and easy to understand, where you can input the upper reinforcement, the lower reinforcement, and here you can give some condition for the calculation of the additional reinforcement. And the colors here will help you to understand what's happening. The blue color for the corner bars, it means those bars will be constant everywhere inside my project. And here those additional color, it's mean this kind of reinforcement is not necessarily be on the final output, but it's depend on the calculation itself. So if the reinforcement is bigger than those 4 bars, then SIA engineer will add 2 bars here and 2 bars here. We can see that later during the live demo. After defining or calculating the provided reinforcement, also SIA supporting you by giving you a nice check. Some of these checks regarding the how economical your design is by comparing the provided reinforcement with the required one. Some of them it's just for safety, to give you an overview about what's happening in your member, so you can compare 2 diagrams. The lower part is the provided reinforcement, and this curve is for the required reinforcement, so I can feel my factor of safety easily when I look inside the diagram. If we talk about the output, then the output we try to make it very simple with a nice table. With also we try to use some colors inside it, green and red, to guide you if the unity check is okay or not. And you can see from this figure that we're showing you 2 cross section in the same place, but one of them for the required reinforcement, which is mean the required reinforcement due to the internal forces, and the second one it's the provided reinforcement, which is provided by you and designed by SIA engineer. So the blue color here again, I'm repeating a little bit this point because it's very important. The blue color here, it's mean you decided to add 4 bars inside the cross section, and you gave the option to SIA engineer. If those 4 bars is not enough, then SIA engineer can use extra 2 bars between them. And as long as the required reinforcement was 4 bars, then your 2 bars on the top side will not be enough, and SIA will add extra 2 bars for you. But those 2 bars will not be on full length of the member. It will be just where it is required. And if we look also inside the detailed output, we will see nice formulas from the Eurocode explaining to you how SIA calculate all these information inside inside the standard output. So you can consult the detailed output to understand what's happening, and you can send even this detailed output to the company which should check your design, and then the communication between you and that company will be much easier, because everything has been explained here in a nice way. From the speed point of view, I would like to tell you that I try to make this complex, two twin complex, and I calculated the required reinforcement in the slab and required reinforcement in the beams and the column, and I compared the result between the new concrete module and the old one from SIA Engineer, and I discovered that now we have 1.5 times faster when we design 2D member and 3.75 times faster when we design 1D member. This is quickly the content for 1D design. As I mentioned, it is just a revision for you because it's already released since 16.1 of SIA Engineer. Now we can talk a little bit more about the design of 2D member. Of course, you can calculate longitudinal reinforcement, shear reinforcement, and as well as you can do some cracks calculation. Then you can go to the long-term deflection and check if your slab is okay for punching or not. The first part is the calculation of the longitudinal reinforcement. I just mentioned a few minutes ago we have different workflow to calculate the reinforcement for 1D members. We have also a different workflow to calculate the reinforcement inside the slab. And if you are familiar with the design of 1D member of SIA Engineer, then you will find this part is very easy for you because in fact we are using the same logic. Here, the first of all, you can calculate the required reinforcement, and I'm showing you 4 images because you can calculate the required reinforcement in X, in Y, top and bottom. So in all 2 direction and 2 location. Next option, I can design my slab by defining a basic amount of reinforcement, and then the software should tell me where is the additional amount of reinforcement. So if I look inside the internal forces, I can predict for this bending moment I need, for instance, something. Then I can define a basic amount or a constant amount of reinforcement inside my plate. So here I'm putting 524 millimeters square, and then SIA will tell me that your amount of reinforcement is not enough in this point and you need extra reinforcement. So the colors and all that can help you to understand what's happening. When you finish the design of longitudinal reinforcement, you can go to the calculation of the cracks, and SIA can calculate the cracks on the upper and on the lower side. Also in the output we can explain to you where is the location of the cracks, the direction, the stresses in the concrete, and how much the limit. The unity check and the colors that we use for the unity check, all that we think it could help you to understand what's going on in your structure. We can see now that directly in SIA Engineer, and for that I prepared this little bit strange example. I modified my slab to show you different cases within our topics for this webinar. First of all, I will go to the design of 1D member. Before missing this part, this is the concrete menu, the new concrete menu. I will close it. Here we have concrete and concrete advanced. Concrete advanced, it's mean the old concrete from SIA Engineer. Why we call it concrete advanced? Because it's containing advanced topic like pre-stress, post-tensioning, fire design, and all these things which is available in SIA Engineer since long time ago. But this is the new concrete which is including, as I mentioned, 1D and 2D design only at this moment. And here I would like to show you the design of 1D member, but let me select another model. For that, here I can calculate the required reinforcement for beams. For instance, here I'm selecting a layer, so I'm asking from SIA Engineer to show me the calculation only for beam. Then I can select the load combination, and I will ask for the required reinforcement. The calculation should be fast, and then SIA telling me that your reinforcement is equal to something like 2 diameter phi 16 on the bottom side, and here on this member I need 4 bars diameter 16. On the upper side here I need 4 bars diameter 16. So as you can see, quickly I can see all the result inside my structure. Many software, many tools today which is available in the market, they are dealing with the members by members, so I cannot see the calculation of my reinforcement for all my elements inside my structure in one time. But this is not the case in C Engineer because I can see it easily. Then this is the required reinforcement. As I explained to you, I can use 3 different workflow. I can add some reinforcement directly, and here it's telling me 3 bars. I will add 2 bars, see what will happen. I have some reinforcement, and then I can go to do some checks. In fact, I need to run. Yeah, so I have the capacity. I can do the capacity for this element, current, and now see checking if the reinforcement is enough or not. And of course it's not enough, because you remember it was required 3 bars on the bottom side. But what I would like to see, how nice the unity check and the colors that we use for the output. If we can go to the brief output, SIA telling you some useful information about your case. You can go to the standard output also, and then SIA telling you what happening. Another workflow, it's let me delete first the reinforcement. Another workflow, it's as I mentioned, by defining some provided reinforcement directly. And in my case I have rectangular, as you can see from the design default, which is mean the place where you can as a user add your reinforcement directly inside your structure as a data, not as a real bar. So here it's easier from the input point of view, because if I open it, I can see its upper lower reinforcement. I can do the 2 bars 16 top, 2 bars bottom, and here I can use different options. I will not explain all of them, but here I'm saying I'm giving a condition to C Engineer. If the 2 bars on the top side is not enough, add 2. If the 2 bars on the bottom side is not enough, add 2. So let's check what will happen. In my case here, I should see 4 bars on the bottom side. I will go to the required again, and current, and I will go to the provided reinforcement. What we will see, I see that SIA telling me you need 2 bars plus 2 bars, and this is very correct. I remember from the IS required, it was the 3 bars. Can show you 3 bars, but my condition was 2 plus 2. So SIA following my condition, 4 bars on the bottom side, and here 2 bars plus 2 bars. If I go to the standard output, then I can see something easy to understand. Here I need 2 bars on the bottom side, which is could be at this point, and I added 4 bars. Another point on the middle of the span, I need 4 bars. No, sorry, on the top side I need 4 bars, and SIA calculated the 4 bars for me. Here I need 3 bars from the yes required, and me as a user I decided to put 4 bars, and then I can see the unity check. I can send all these results to the draftman to make the final drawings. The next workflow is by using section check, and section check it exists. If you click on section check, then here I can select the load combination, ULS, and I will select section check. And when I click on section check, I can select this one at the middle, and the unity check, of course it will be not okay because I need to increase the bottom reinforcement, but still the detailing provision showing me some issue, which is the distance between this bar and that bar, it's exceeded. The maximum distance should not be more than 350, and now I'm using 418. So easily I can solve this issue by using this layout, and in that case I can use 3 bars bottom, and this is just for detailing issue. Another issue is just coming telling me that for the shear the calculation is not okay because the spacing between the stirrups is 200 currently. I should modify it to 150. Easily I can do that, 150, and then that's it. I have my final reinforcement here. I can save it, and when I save my result, I can see this flag coming on the member. I can copy this flag to another members, and in one click I can check all these members if they are okay or not. If you remember, I mentioned something about can we design members for SLS and ULS. Yes, you can do that with this method. So now what I'm doing, I'm using ULS, but I can use SLS, and I can tick which kind of SLS check should be performed. And now see checking all these sections for SLS, and I see that it's 0.98, which is okay. This is in fact what I would like to show you about the design of 1D member, and now I can switch to another project where I prepared to show you the calculation of 2D member. Here I have this plate supported by some columns and walls. Then I can calculate the required reinforcement, selecting of load combination, make some filter for the result, and click refresh. SIA telling me that the required reinforcement for the top side on X direction it's 522. I should write this value down on a piece of paper because I will need that. Then I can go to the Y direction, and it's 602. If I go to bottom reinforcement in X, it's 358, and bottom reinforcement in Y is 345. This is the calculation of the required reinforcement. The question is now, it's up to you what kind of workflow you would like to use. If the calculation of hairs required is enough to you to send it to the manufacturer to make the mesh, that's it. You can say I finished the design. In some companies this is not enough, and they should make the output more practical, because now we calculating the reinforcement in each mesh, and this could be not practical enough. So I need to make my result more practical. How can I do that? I can do that from the design default. If you remember, we did the same for 1D by adding some reinforcement from this menu. I can do the same, but now for the plate. If I click on use template for provided reinforcement, then SIA will show me the plate where I can define some reinforcement. I can use something from the predefined library, and or I can modify the content. In my case, let's talk about this example. We said for the top reinforcement 1 plus, we need 508 or 06. So what I'm putting here as a constant amount 524, this is too much. So I will say 0. Don't put anything on the top side. And if the 0 is not enough, then I can use different possibilities from here by fixing the amount. If the 0 is not enough, then put diameter 10 or with the spacing 150. This should cover. And the same thing I can put it here. So I will use for the top reinforcement, but not everywhere, because I added this one as a 0. It will be only where required with the value of 524. For the bottom reinforcement, we need much less, so I can use diameter 8 in both direction, and I can put the spacing 250, but this will give me 201. What I want to see is 350 or 360. So again, I can fix this amount by giving the same value, diameter 8. So in total, what will be 250? It will be 200, it will be 400, and this should be quite enough, right? So now we defined our reinforcement, and we just need to change the value from the required to the provided reinforcement. And let's start from the top side. I'm expecting the result will be in two colors. One color, which is blue, should be for the calculation. Yeah, the blue color, it's 0, where there is no reinforcement on the at the middle of the span. Only the reinforcement, it will be required on the top side in some cases, but I see on this plate I still need top reinforcement. But this top reinforcement, it's fixed amount, which is diameter, as we said, diameter 10, spacing 150. So 522, this is required. I provided 524. But on the other direction, I need 576, but I provided 524. It's up to me to say, yeah, it's very small issue. I can ignore it, or I can increase my reinforcement. On the lower side, my reinforcement is enough without extra bars. This is 1, this is in y direction, 2 values, and then I can go to the bottom reinforcement. And on the bottom side, what I see two colors. The first color is diameter 8, spacing 250, and the red one, it's diameter 8 but spacing 125. I can print this one, I can send it to the draftman for a final conclusion. So here I can say that my final result is okay and I have no issue. To be more comfortable and to check if everything is fine, I can go to required additional, and this is extra verification for you to check if your provided reinforcement is okay or not. Normally you should get all the values as a 0. So let's check the first value, 0. That's mean your provided reinforcement is bigger than as required in y in the direction of 1 plus. If we go in the direction 2 plus, we see a small issue which is coming from extreme stresses somewhere. Here I see some extreme stresses. It's up to me to ignore it or to increase the reinforcement a little bit. I can see it's the value, it's 79 millimeters square, so personally I will go to ignore this value. Next, 1 minus 0 and 2 minus should be 0 also. So my final reinforcement is perfect. This is the content regarding the calculation of 2D. Now I would like to check if my reinforcement, which is a provided reinforcement, okay for the calculation of cracks or not. In fact, here I can select the load combination for the calculation of the cracks. Then I can tell the software which kind of reinforcement I would like to check for the cracks. Required reinforcement or provided, or even I can put some extra mesh, additional mesh or practical mesh like that to the slab and check if it is okay for the cracks. In my case, I'm checking the provided reinforcement, and for the calculation of the provided reinforcement, I'm using this combination ULS. I will click and now SIA checking if the reinforcement is okay for the cracks or not. SIA telling you that the unity check it's 0.82. That means there is some cracks appear, but I don't know if it is appear on the top side or on the bottom side. So I can change the value from here. I can see the top side reinforcement or top side cracks, which is this one, and I can go to the lower side. There is no cracks, 0, and also I can go to see the standard output where I can see more details. And here we're showing you some basic information about the case that you have, internal forces, and then we're telling you that you have cracks in X direction on the top side, located within 130 degree, and the stress is in that point like this, and the size of the crack like that, and the unity check is still safe. This is for the provided reinforcement. If I go to required reinforcement, for instance, to see what it will be, because my provided reinforcement, of course, bigger, and I see that the cracks it's still safe, and the unity check it's higher. So it's very simple. You don't need to spend a lot of time for the crack verification. In fact, this is what I would like to show you regarding the design of longitudinal reinforcement with the cracks calculation. And now I can go back to my presentation, and then we can talk about the content for punching. What we can do for the punching. In fact, we can do punching for slabs and foundation. Good news that we have SIA automatically recognize the shape of the column. Please look on this column. This column is a rectangular column, but the software in the past, because in the past we had some other solution for the design of punching. In the past, you have to tell the software what is the case of that column. Is it rectangular or is it circular? Is it a corner column or is it a edge column? Now all that it's not required from you, and I guess you will save a lot of time because it's automatically recognized. Then we have two methods for the calculation of the beta factor. The simplified method depending on the location, and be careful when using that because this method has some limitation from the Eurocode. And also we have a formulas for the calculation of beta, which is also from the Eurocode depending on this article. Two different types of reinforcement you can use as a longitudinal reinforcement to check if the punching is required or not. Finally, the unity check as a color, green or red, will guide you. Beside also the size of the critical control parameters for the calculation of the cracks will be also drawn on the screen to tell you what is the size. In case that the resistance of the concrete within the longitudinal reinforcement both will not be enough, then SIA will go to calculate some punching reinforcement in this method only, radial. Next, here I already explained this point to you. How we improved the workflow, and now we have automatic things, and this could save the time. In this point, what I did, in fact, I made a kind of comparison between the old modules for the calculation of punching with the new one to see how much time I will save. This is just for my personal use, but I decided to share that with you, in fact. Here I have the same plate, and I decided to calculate the punching in both two options. Here in the old method, I need to tell the software about the location of the nodes and the condition of the connection, and here I don't need to do that. So what happened, in fact, I spent 20 seconds per column just to tell the software about the location, and this consumed from me 8 minutes. With the new solution, I don't need to spend that. And after, I have to give some eccentricity. As you can see from this image, the column is not located on the edge, it's shifted a little bit inside. And in the past, in order to do that, I have to spend some time. Now if you did it, then it's automatically recognized. Finally, I can tell you that for this simple slab I saved 11 minutes, and I saved more than 65 clicks. We can see that now directly in SIA Engineer. And first, let me check punching for this model. We calculated provided reinforcement in the previous step. I select the load combination. I'm asking to show me the unity check in every single node. So when I click here, what will happen? SIA now checking the punching in each node and checking if the punching is required or not according to this load combination. The calculation quite nice and fast. Let's show it like that. As you can see that SIA telling you that all the unity check is okay. You don't need to go for punching shear reinforcement. What's interesting to show you is how SIA calculating the critical parameter. You see, for this point, SIA understand this point is connected with 3 plates, and here it's with 2 plates, and all that is done automatically. I don't need to do anything. Just one remark: if you have a wall connected with a slab, then we are not supporting punching for walls at this moment. I would like to show you also the result on another another project, in fact, to show you some different cases could happen. You see, I have a curved slab here, but still SIA Engineer capable to calculate the control parameter for the calculation of punching. And then here I see some different color, which is blue. What's the meaning of that? If I select this node alone and show the preview output, what SIA will tell me? SIA will tell me that for this node, I'm selecting, in fact, 2 nodes. Yes, 2 nodes. So I need just this one. So in this node, SIA telling me that the unity check for the compression for the citruses in the concrete, it's exceed the limit, so it's 1.1. That means I need to go for punching shear reinforcement, and then SIA calculate the punching shear reinforcement. Beside this calculation, you can find some useful information, location of the column internal, and some other issues which could be useful for you to understand what's happening. And the error and warning system, as you can see, SIA telling you there is a warning here. Punching shear resistance is not sufficient. To avoid design of shear reinforcement, try to increase the amount of longitudinal reinforcement. So if I go now and add extra amount, let me exaggerate, I will put 1000. Let's see what will happen. So now SIA checking the reinforcement first, and it will find it as you can see now the unit check become green, and it's mean that you don't need to go for the punching shear reinforcement. I hope it's clear for you. It's very simple and easy to use. Next topic, it's the calculation of long-term deflection. You can do CDD calculation in SIA Engineer, and this will be according to chapter 7.3, 7.4.3, and we do the calculation for long-term deflection for 1D and for 2D in the same time. Good news in this version that you don't need to define the concrete combination. If you are familiar with the old CDD, then you will see that you have to make a load combination in the past, and you need to tell the software this is the combination for the calculation of immediate deflection and some combination for the calculation of the creep deflection. In this version, all that it's not required, and you can do that, SIA do that automatically for you, and probably for this point you will save some time. You can use 3 different types of reinforcement for the calculation of the long-term deflection, and of course the unit check will be available to guide you if everything is fine or not. From this table, I'm trying to show you how SIA calculate the step-by-step deformation, immediate, linear, and short-term deflection, creep, additional. All this information will be available inside the brief output of the CDD calculation. Before going to SIA engineer here, I'm trying to mention to you that the calculation of the creep coefficient in this version also automatic, just like in the past. Maybe someone will ask how we calculate, how we make the load combination in SIA engineer. And in fact, what's happening, what it's required from you is just to define the load cases that you need in your project. Self-weight, permanent loads, and some variable loads. And then SIA will exclude all these load cases to linear one. And for the critical one, SIA will generate all these combination as you can see. For instance, I'm taking now the immediate deflection is taken into account only the permanent load, so load case number 1 and load case number 2, and also point 3 from load case number 3, which is a variable load, but it's with long duration on the structure, so it will behave as a permanent load. All that, as I mentioned, it's automatically implemented in SIA Engineer, and what you need to do is only generating the load cases. Beside the calculation of the CDD here, it's the warning system. And with the warning system, it will be presented graphically on the screen and within the output. So within the output, SIA trying to explain to you what's the issue in your structure and what you can do as a user to solve this issue. For instance, the limit additional deflection in Y, it's blah blah blah, and here try to increase the dimension of the cross section. So this kind of interaction between you and the software, I guess it could help you to achieve your design. As I mentioned, for the calculation of bunching, I tried to make a comparison between the old one and the new one. I did the same here, and also within the improvement that we did from the automation point of view, you can save a lot of time. I have this structure, and with the old CDD, I cannot mix the result of 1D member with the result of 2D member, but you can see from this image that the result can be shown on the same screen in the same time. From the timing point of view, generating the load combination for the CDD consume 50 seconds from me, but within the new version all that is not required. So generally I can say that we have 4 times faster in new CDD calculation compared with the previous one. We can see that now in SIA Engineer, and for that I prepared this model. This model consists of a slab with beams supported by columns and walls. And to activate the CDD calculation, just remember something. You need to go to functionality, and in the functionality you have to click on code dependent deflection. In my case it's OK, and then go to the concrete design, and in the concrete tree, in the check part, you will see code dependent deflection. The menu for the code dependent deflection, it's quite similar to the calculation of the cracks of the slab or the calculation of bunching. Selecting filtering or selecting the member. Some selection for the combination for the calculation of the long-term deflection, and here I can select which kind of reinforcement I would like to use for the calculation of punching. In my case, I will use, for instance, the required reinforcement, and then SIA asking you which combination you would like to use for the calculation of the required reinforcement. I'm telling it is ULS, and that's it. I can use the unity check or the total deflection. Let's click on unity check, and I will click OK. And now what's happening? SIA designing the reinforcement in beams, then designing the reinforcement in the slab, and exploding all the linear combination and do the calculation of the linear and nonlinear stiffnesses. Finally, I have the result for my beams because I selected beams here. And this is the unity check. The unity check for beams, it's okay. I can go to the total deflection. 3 minus 3.8, 1.6. This is the calculation for beams. If I want to see the result for the slab, I can select only slab, but I can do something much faster. I can select everything in one time. And now see, I will repeat everything. Refresh. So designing everything, and I will get the result for everything in my structure for beams, columns, and the slab. Let's hide this one, and we can see the result here. Now I can use the filter without influencing the result. I can go to layer, I can see the result on the slab. Why I'm saying without influencing the result? Because something you have to keep it in your mind. If you decided to select only one member from the beginning, if I selected only this column and I ask from SIA engineer to calculate the CDD, then SIA will calculate the real stiffness in that member and assuming some linear stiffnesses around that member. So that's why I'm telling you, be careful about selecting only one member. You can select everything from the beginning and then make the filter to see the result for different element. To make that more practical, I can select this element only, current, and I will select layer, but not layer, no. So now by selecting everything, the total deflection for this member it's minus 9.2. I can delete the result, tools, clean. So I'm deleting all the result, and then I have to recalculate my structure. This step is just to show you what's the difference between selecting one member or selecting all members together. Checking now, I will select only this member. Load cases, I will select the same combination, required reinforcement, and click. So now SIA checking only this member, calculating, designing only this member of I selected all. So current, unity check total, it's 3.1. For the same, I will change it to all. Everything it's here is the same, provided total deflection, but everything has been selected. Remember 3.1. And for this I can see member, This is 2D. Member current, and it's 9.1. So you can see the difference between 3.1 and 9.0. This is just because in if you select one member, then we take the real stiffness in that member and some linear stiffnesses around it. If you selected everything, then the result it will be accurate. If we look on the output, then you can see all the necessary information in the output, and also I can print some explanation on the result if there is error or something. Sia explaining to you what's the terminology that we use, and if there is a warning or something, Sia will tell you what's happening for the CDD. I hope this part also was clear for you. And now we can go to the last part, which I would like to mention to you that the speed has improved in version 17 for many reasons. As I explained to you that we modified the workflow, we automated the workflow just to improve the speed, but also and thanks to the multi-core processing system where we can use the capacity of your laptop or your PC. Here I'm trying to make a comparison for the same model between using the old concrete and the new concrete, and you can see with the old concrete SIA use only 20% of the CPU. With the new concrete we using 100% of the CPU. So as much as you have a powerful laptop, as much as your calculation will be fast. But in the past, even if your laptop it was powerful, that will not influence the calculation of SIA engineer. Remember, you can design any kind of a cross section, no problem how it look like, as long as you can model it in C Engineer, as long as you can calculate the reinforcement for it. The transparency of the software should be very easy now and very clear for you to understand what's going on inside the software, so we don't have a black box anymore. And this can help you to understand your solution, or it could help you to make easier communication with another companies who's dealing with you. All these points I would like from you to remember when you test CI Engineer, when you try to use CI Engineer, and I hope you enjoyed this webinar. I'm sorry that the time was not fully enough for me to cover all the topics that I would like to say. Thank you very much for your attention, and please, whenever you have any feedback, whenever you have any recommendation about the concrete design, please, this is my email address. I am the responsible for the concrete design. You can send me your ideas. I can visit you. We can discuss together to make the software easy to use from your side and good also for us. Now we can go to read the question, and I will try to answer this question.